Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 1. It says, the current carrying coil C1 is paired with another coil and EMF capital E is induced in coil C2 when the current through C1 drops to 0 from a non-zero value within 1 second. If the coil C1 is paired with another coil C3, an EMF of 0.7 times E is induced in it for the same rate of drop in the current through C1 as earlier. What is the ratio of mutual inductance M12 to that of the mutual inductance M13? So let's take this. For case 1, we are having a coil C2, and this coil C2, it is paired with coil C1 such that the current carried by C1 is I1, and we know whenever there is a rate of change of current in C1, there will be an induced EMF in C2. So the induced EMF in C2, it can be calculated as capital E is equal to minus mutual inductance times the mutual inductance of this pair of coil M12 multiplied by rate of change of current in the primary dI1 by dt. Alright, and it has been given to us that this value is E only. So the EMF E is induced in coil C2. Now we have paired one another coil C3 with the coil C1. And again, the current flowing in the coil C1, it is I1, and the mutual inductance for this pair of coil is M13. But this time the EMF induced in C3, it is 0.7 times E, and that has to be equal to minus M13 times the rate of change of current in the primary coil, that is C1. So these two equations we got. Now we can divide these two equations. So this is equation 1 and this is equation 2, and dividing equation 1 by equation 2. So let's divide them. E divided by 0.7 times E is equal to, this minus sign gets cancelled out with this minus sign, and dI1 by dt again cancelled out with dI1 by dt, and we are left with M12 divided by M13. Other terms will be cancelled. So this E gets cancelled out with this E, and we are left with 1 upon 0.7 is equal to M12 mutual inductance of coil 1 with respect to 2 divided by mutual inductance of coil 1 with respect to coil 3. And it will be equal to 10 by 7. That will be M12 by M3. And 10 by 7, it is equal to 1.42. So the ratio of mutual inductance of coil 1 with respect to 2 to coil 1 with respect to coil 3, it is 1.42. So option C is correct. Thank you. Keep learning, keep practicing, keep excelling.